LeetCode Problem number 417, Pacific Atlantic water flow. So this problem gives us a m times n rectangular island that borders both the Pacific and Atlantic Ocean. So here it says that the Pacific Ocean touches the island's left and top edges, while the Atlantic Ocean touches the rest. And here it says how it partitions into a grid of square cells. It's an integer matrix, and each integer represents the height above seawater of the cell at coordinate R and C. Right, so basically what it means that the higher the number, the higher the land, basically. So it says here that the island receives a lot of rain, and the rainwater can flow to neighboring cells directly north, south, east, and west. So this means that it can only flow up, left, right, and bottom. And the water can flow from any cell adjacent to an ocean into the ocean. So what we have to do is to return a 2D list of grid coordinate results, where the result will denote that rainwater can flow from the cell RC to both Pacific and Atlantic Oceans. So basically what it wants us to do is to find a cell where if rainwater were to be dropped here, it can flow to the Pacific Ocean and to the Atlantic Ocean as well. So this means that what we are looking to do is from each edge of each ocean, we will need to do a depth first search, right? We need to do a depth first search until we have reached the number that basically we cannot increase to anymore, right? Not sure whether I'm making sense, but if we look over here, this 5 and 4, these two cells cannot flow into 5 and 4, right? Because the land here is lower than the land over here and over here as well, right? But then again, it can flow over here since it's less than equal, but the only cell connected to this 4 is the 5 and this 2, right? And which if the rainwater were to fall somewhere here, it is basically trapped, right? It is trapped by the 4 here, the 2 here, and the rest, obviously. Okay, so with that said, the goal is still the same. We have to search through from the edges, from one edge, and then we deferred search. We deferred search until we cannot go up anymore, technically speaking. Basically, it would go down. Not sure whether I'm making sense here, but we will need to check for every cell that we can always be moving up, basically. So that's how water works in a way. We must search so that our water can only move up from one ocean to the middle. Right, so we're tackling this problem the opposite way. Instead of starting from the middle, we're starting from the edges to find out which water will reach the highest point of the cell that can flow both to the Pacific and Atlantic Ocean. Yeah, so as I mentioned, we will need depth first search for this. So here in my depth first search function, it's pretty much similar to all depth first search functions, but instead I have a directions vector here, and for each cell that we visit, I will mark that cell as true. Actually, I think we should start with the main function first. So here I have a m which represents the size of the height, mn which represents the size of the column, right? Because they could be different. Here I have two 2D arrays, 2D vector, both Pacific and Atlantic, and I'm initiating all of the cells inside these two grids to false, which indicates that we have not visited, or which indicates that the water cannot flow to this cell in a way. But for simpler sake, I'll just mark it as visited or not. So as I mentioned, we will need to perform depth search on the edges. So here there's one, and here there's another one. They both work the same way. It's just that the x and y values are different. Right, x and y values are different. In this case, more like the I and j values are different. Okay, so for this for loop, we'll be looking at the rows over here, and for this one, we'll be looking at the columns. So in the depth search function, whenever we have visited a cell, we will mark it as true. So what I mean by that is, let's say, just for simpler sake, I'll have a visual example. Okay, so let's say this is the Pacific one, right? This is the Pacific grid, and this is the Atlantic grid. Okay, so we know from the Pacific Ocean part, we will need to the start from the edges and check from there, right? So in this case, let's say I is 0. So we will be starting from the left side for the Pacific, and for the Atlantic, it will be from the right side. Okay, so in the depth search, let's say I'll mark this as true, which will be 0. Let me just help. Yeah, so it's easier to see. Yeah, so I'll mark this as 0, and then from there on, I am recursing to see whether or not the height is more than the height that I'm going to, which is x and y over here. We have calculated which direction we're going to, is more than our current height. So for this instance, since this was 1 originally, this was 1. So in this case, the cells here can flow into our 1, right? So we can technically mark. So we start from here first, right? So we mark here first. This will be 2, and since it equals, it will be 2. It can flow up. So 3 is more than 2, right? Oops. 2, and then we have 5 here, right? This corner is a no-brainer because it is at the edge of two oceans. But let's continue from over here. This 3, it can flow, right? 3 to 1, it can flow here. For 2, it can flow as well, right? From 2 to 2, 2 to here is the same thing, smaller, smaller, right? So here all of the rows can be considered as well. Okay, this 4, the reason why this is available because it can flow through the 4 over here and then moving upwards. So we can mark this as true as well. And over here, we can definitely flow to the left side of the Pacific Ocean. Here we can flow, we can pass here. Okay, so here we can't because this tree is surrounded by two bigger numbers, and there's no other ways for us to visit the Pacific Ocean from this cell. So technically speaking, we cannot mark this as visited, cannot mark this as visited. This one we can, this one we can, and the rest we cannot. Okay, so this is what our cells for the Pacific look like. Now for the Atlantic, we are going to do the same thing, but we are starting from the different edge, and it will look something like this. Let's do it quickly. So it will look something like this, right? Where the water from any part can flow to can flow at most to these cells, right? So now that we have both grids written out for us, then what we do is we create a result vector, another 2D vector, and here we iterate through the grid, and then we check if both of the grids we visited, right, at both grids. For instance, this one we have visited, this one I'll just put a 0 so it's easier to see. This one we have visited, this one visited, same, right? So if you notice, the axis here overlap the axis here as well, right? Some of it at least. And what we are interested is the sum of it, right? Which are the ones that I've marked as O's over here. And what we do is, since both of them have been visited in both grids, we can just push back the coordinate into our result, and from there we return the result. Okay, this is a bit mouthful, but hopefully you guys get the idea behind the logic. Yeah. So all in all, it is a pretty straightforward question and a straightforward solution from my end. Basically running depth first search repeatedly for both edges, for both the Atlantic Ocean and the Pacific Ocean. And then from there, we work our way to the middle. And if both depth first search meet in the middle, means that the water can flow and connect from that specific cell that we have met at. So once that is calculated, we will then push the results into our 2D vector and return it. Okay, that's all I have to show. Thanks.